This topic is about function notation. So we're going to take you a little bit deeper into more common notation that is used for functions as you get through higher math. All right, so function notation is really just a way to name a function using the letter F. Sometimes we use other letters like G or H, but F is the most commonly used one. And we use that to replace the variable y. Okay, so it's not really just the letter f, it's actually an entire notation. So for instance, if I have this linear function, the output is the y, the input is the x, and then I perform the calculations on x to get that output value. Right? Well, same thing with linear functions. Instead of a y though, I put this function notation. This entire thing represents the output. I'm going to plug in a number and then I'm going to perform this operation on it to produce my output. Okay, so just this is what the notation looks like. This is not multiplication. It is not f times f of x. You might think that because of the use of the parentheses, but that is not correct. Okay, it's not multiplication. It is notation. I'll show you how it works. Let's take a look at our first example, which says evaluate this function, which is described by taking your input, multiplying it by -4, and then adding 7. That's really how you want to look at functions, is that what does it do to the input value? All right, the inputs will be -2, 0, and 2. So these are our domain. Let's write that. This is the domain. It's already listed from least to greatest, no repetitions. That's good. All right, and so let's see how this plays out. How do we evaluate a function? All right, so I'm going to take my function f of x. Let me rewrite it. Okay, and I'm going to think of it as a rule. So here's how I think of it. All right, so I'm going to take out the letter x for a moment and instead just put parentheses in its place. So when I'm using a function, I place the number in here to represent, to tell the world that this is my input value. That's all it means. It's just a notation. We don't do any math over here. The math occurs over here. So I'm going to take that input, plug it in, and then perform these operations. So we'll start with x equals -2. Okay, so then I write f of -2, and that's how we say it, f of -2. So the function evaluated at -2 is -4 times the quantity -2 plus 7. All right. The only math we're going to do is here on the right. Again, this is notation. Don't do anything with it. So let's evaluate that. Multiply, we get 8, and then bring the 7 down, and then add those together to get 15. So the function at -2 has an output value of 15. So that's my first output. So you can think of this as an ordered pair. -2 produces an output of 15. Okay, let's do it again. All right, so that was for x equals -2, and now we'll repeat that. X equals 0 is our next input. So f of 0 is equal to, we perform the same operations, -4 times the input of 0 plus 7. Okay, so do the math. Product first is 0 plus 7, and that simplifies to 7. So input of 0 produces an output of 7. That's the same as this ordered pair, 0, comma 7. And then finally, so that's this one. And then finally, we're going to do x equals 2. All right, so plug in 2. That's equal to -4 times 2 plus 7. All right, so that produces an output of -1. And so I have an ordered pair I can plot to -1. If I asked you what the range is, you would simply just, if the domain was these values, what is the range? You'd say these three numbers, but of course you put them in order least to greatest. So our range is equal to, the lowest number in the range is -1. And then the next one, so we have 7 and 15, so 7 and then 15. All right. All right, another example. All right, so I wanted to show you that we don't always use the letter F in a function. Sometimes we use different ones. So H is another common one, H, and this is called h of x. Here is a linear function model. So we can see 2/3 x. The 2/3 would be the slope of the linear function, and -5 would be our y-intercept. And we're supposed to find the value of x for which the function h of x is equal to -7. Now remember that this h of x is a representation of the output. So we're telling you that the output is -7. That's my y value. Okay, so what we're saying is, what is x when y equals -7? All right, so here's what we do. I want to know, so remember that this is representing, after you perform the operation of plugging in x, you get a y value, right? So this represents the entire thing, represents our output. So I take that number, I want my output of 2/3 x minus 5 should be equal to -7. Okay, you do not plug this in to where x is. X is for input numbers. I want to know is, after you plug in x and you perform all this, you end up with -7. What was that original x? So you make these equal to each other. That's all there is to it. So when you see the question asked in this form where they tell you the output number, you set the output number equal to the function. Okay, so let's solve this equation. So I'm going to start with isolating the variable. I'm going to add 5 to both sides. Okay. And then how do I undo this? I'm going to multiply both sides by the reciprocal. What is the reciprocal? All right, reciprocal is 3/2. So multiply by, or just write it like this, 3/2. 3/2. All right, product of reciprocals is 1, because 3 divided by 3 is 1, and 2 divided by 2 is 1. So there's 1x. Got to review that all the time. I mean, that's one that is often forgotten. That's why I spent a little time on that. And then over here, I'm going to multiply these two values. Of course, I have a fraction, so I'm going to put the -2/1. And then if I can reduce, I will. And I see that the 2's, 1, 2 in the numerator, a 2 in the denominator, we can reduce those. Divide by 2, I get 1's. And so I'm left with -1 times 3 over 1 times 1, which is -3. So when the output is -7, my input must be -3. Now if you want to verify, if we want to do a quick check step, we'll plug it in. So we take h of the input, so h of -3, all right, is equal to, and then remember how we evaluate. We're going to plug in, instead of the x, we replace it with -3. So 2/3 times, and then -3. And then we're subtracting 5, so -5. All right, and then we evaluate this, equals, okay, I'm going to put this over a 1. Reduce these out, so that's a total of -2 minus 5. Bring that down. Combine those, -7, check. Okay, I got an output of -7. It works. All right, and then the last example, we're going to graph this linear function. So what do you think is best? How would you graph it? Perhaps you'd want to make a table of values. So we could make a table. It would look like this. We just, instead of y, we just put f of x. And then you choose some values. How about -1, 0, 1? You could do it like that, and then you plot those values. Another way is, since this is in the linear form, we could, well, let me go ahead and finish this. So we'll just practice it. F of 1, right? So -1, we're plugging in -1. All right, so what is f of -1 if we plug that in? All right, so -1 times 2, -2, add 5, that's 3. So that's our output, and we have the ordered pair -1, comma 3. Plug in 0, so we'd have f of 0 is 2 times 0 plus 5. That's 0 plus 5, which is 5. And so our ordered pair is 0, 5. And then plug in 1. So in f of 1 is equal to 2 times 1 plus 5, which is 7. Gives us the ordered pair 1, comma 7. Okay, so we have some points that we can plot. All right, another thing that you can do is just recognize, as I was trying to get to earlier, this is just the linear pattern, right? So we have right here, 2 is slope, and then we have our y-intercept. Okay, so let me list those out. So slope is 2, which of course we'd write as a ratio, so we can do rise and run. Positive in both directions, we do the positive directions, or we reverse and do 2 negatives. The y-intercept is 0, 5. Okay, and then we graph that. I'm going to use my ruler. Okay, I can see I've got some very large y values, 3, 5, 7. So I'm going to make sure my x-axis is much lower so I can graph some of those. Oops, a little crooked. Okay, that's all right. All right, x, and here's my y-axis. All right, so y-intercept of at 5, counting by ones. My slope is 2 over 1, up 2, right 1. Or reversing, down 2, left 1, down 2, left 1. And do want to point out that as I did that, we did actually plot both of these, all 3 of these points. Of course, we started with, we've got 0, comma 5 right there. Well, that's right here. 0, comma 5. 1, comma 7. 1, 2, 3, 4, 5, 6, 7 is right here. And then we also have -1, 3. -1, 3 is right here. Okay, so you could have plotted those 3 points, but instead we use the slope, the linear pattern. All right, anyway, so it's a functions, and we're going to connect those up. No restriction on the domain, so we assume it's continuous, unless they otherwise tell us. All right, so there is our graph. Time for you to practice.